The universe is an infinite fractal made up of an essentially infinite number of cosmic explosions called the Little Big Bang. If you look at any science textbook before 2006, you will see that Pluto was one of the 9 planets in our solar system. But that is no longer the case. Nearly 17 years ago, the International Astronomical Union, or IAU, redefined Pluto's status and ruled it out of being a planet. Now the IAU is discussing the issue again because NASA has provided clear images of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our solar system to explore the first images of Pluto in our history. If you are interested in staying updated about the universe and its surroundings, please subscribe to our channel. Don't forget to like this video, share it to reach more people and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, but the vastness of space raises many questions. This is the pioneering project of NASA's James Webb Space Telescope trying to find its world. This monumental project is based on past NASA missions, and it is great to repeat the special discoveries of prehistory. We are of course curious to learn more about the Big Bang and how our solar system gave life to one of its planets. But the James Webb Telescope is looking into the future of our solar system, revolutionizing our understanding. While it is important to ask whether we need to look back to get definitive answers about the universe and perhaps re-evaluate them, the question of Pluto has been controversial in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it provides, we have more and more information to study our solar system. NASA's $10 billion investment appears to have led to science textbooks being revised to include everything we know about Pluto. This time, it is likely to restore planetary status. Our knowledge of Pluto does not end with the controversial IAU decision in 2006. In fact, James Webb's new and improved capabilities provided the visual evidence needed to strengthen our theoretical understanding about this supposed planet. While previous observations were supposed to help classify which objects were considered planets and which were not, the Union actually had little hard data to rely on. Some believe that the IAU had hastily declared Pluto dwarf planet, but others quickly accepted the new non-planet status. Most space explorers remained unsure. However, thanks to James Webb's exciting discoveries, the question of Pluto's state remains. NASA's first sharp images of Pluto are reshaping our understanding of cosmic history. The first and primary human encounter with Pluto was achieved by the 17-year-old New Horizons mission. In July 2015, the mission reached its goal by passing Pluto and its many moons. It was the first time humans had laid eyes on this space relic and collected the most comprehensive dataset to date. Its moons and surface. The New Horizons mission opened unprecedented opportunities for NASA to explore the Kuiper Belt, a region of deep space. The agency was aware of the need to gain a good scientific understanding of the planets orbiting Neptune and about $50 from the Sun. The most important achievement of the mission was the detailed study of Pluto that is now being considered the dwarf planet and its largest satellite, Charon. But it was also able to take clear images of 4 other satellites, known as Nix, Hydra, Kerberos and Styx. In 15 months, the mission collected a total of 6.25 gigabytes of data, including encounters with Pluto and Charon. What does this data mean for NASA compared to the dwarf planet? At first, the findings were so surprising that scientists had to develop new data models to better understand Pluto's surface and atmospheric conditions. Major changes to the dwarf planet's surface and atmosphere were observed. It was clear that Pluto was evolving far from quiescent at a rate that surprised NASA and challenged what was previously believed. Putative planet. The New Horizons mission was groundbreaking and its encounter with Pluto took place almost 80 years ago. Since then the field of space exploration has greatly improved thanks to technological intervention. With the addition of the James Webb Space Telescope, the possibilities become endless. You could even say we're getting closer and closer to fully understanding our solar system. It's something you don't hear very often, but with the James Webb Space Telescope we're closing the gap. between what we know and what we could possibly know. However, this is the problem with missions like New Horizons and potential opportunities to explore planets beyond the Sun. The problem is the prioritization of resources. Spending millions to study a scientifically important planet can raise questions about the existence of possible life forms elsewhere. Why go to the edges of the solar system? These are certainly difficult questions. But the New Horizons mission marked a turning point in the history of space exploration. This not only opened up new opportunities for NASA to invest in Pluto research, but also sparked our interest in further exploration beyond the known boundaries. In the case of Pluto, a broader scientific understanding of other minor planets is important to its research. Although it lies in a cold, dark region of the universe, the first images of its surface were stunning enough to reveal that Pluto is an active object in our solar system. As they say, a picture is worth one thing, 1,000 words, and these crystal-clear images from NASA give us valuable information. First, a heart was discovered on Pluto. Most of the geological phenomena of this dwarf planet originate from its core, scientifically known as Sputnik planitia. Surprisingly, it turns out that Pluto literally follows its heart. A quick look at NASA's high-resolution images revealed that this heart is white, cold, and almost frozen, as the left chamber of Sputnik's heart resembles a huge nitrogen glacier. It spans millions of square kilometers. Another important geological feature of Pluto's surface is that its axis of rotation has again shifted significantly, a process scientists call precession. NASA didn't know this before the mission. The dwarf planet's basin is in the opposite position than expected. This reorientation has important consequences for understanding the dynamics and evolution of Pluto as a planet. Simply put, the tidal axis between Charon and Pluto affects Sputnik planitia, the heart of the dwarf planet. This effect changed Pluto's orientation so that its basin is more aligned with the tidal axis, previously unknown. We always knew this ancient planet was uninhabitable for obvious reasons. However, it was not known that Pluto's icy surface also causes it to tilt due to its mass imbalance. The core of the heart of the dwarf planet is a 4 km thick layer of ice that most likely contributes to this enormous mass along with tides. This process can cause the planet's spin axis to reorient to balance its orbit. But an ice sheet alone is not enough to create a sharp reorientation angle or significant elevations. As we mentioned earlier, technology-enabled exploration could rewrite our cosmic history, and this is just such a moment. Scientists have also discovered that Pluto is a world with its own ocean. Beneath the thick ice sheets and glacier-covered surface, Pluto's interior contains a vast ocean, which also contributes to the reorientation of its spin axis. This discovery is extraordinary for many reasons, but mainly because it will completely change our lives. Understanding of the planet. The very likely presence of an ocean in Pluto's crust means we can learn more about its origin and formation. What do you think? Let us know in the comment box. If you enjoy the video, be sure to hit the like button, share it to reach more people, and subscribe so you don't miss more content like this. Star.